This is homework number 11, question number 8, and the problem is stating y double prime plus y is equal to secant x. Now, first step we're going to have to do is solve for the homogeneous version. And to do that, we need to set this equal to its characteristic equation, which is going to be m squared plus 1 is equal to 0. And with that, we can find what our m is equal to, which is going to be plus or minus 1i for imaginary. And with that, we find that our fundamental solution for the homogeneous version is cosine x, sine x. Now, the general solution for the homogeneous version is equal to our yc value, which is also equal to c1 cosine of x plus c2 sine x, where our c values are arbitrary constants. Now, our yp value is going to be very similar, yet not similar at all. Our yp is going to be u1 cosine of x plus u2 sine x, where our u1 and u2 are functions of x, not constants. They're functions. And in order to find what those functions are, we have to use the Wronskian method. And for Wronskian method, the first thing we're going to have to use is find the matrices of w, which is going to be y1, y2, y1 prime, y2 prime, which is equal to the matrices of cosine x, sine x, negative sine x, cosine x, which is equal to cosine squared x plus sine squared x, which, using the Pythagorean theorem in trigonometry, that's equal to 1. Now we need to find what our w1 value is, which is going to be 0, y2, f of x, y2 prime. Now we have a problem here because we don't know what our f of x value is. We haven't defined it yet. So we're going to have to go back to our original function and make sure that the highest order has a constant coefficient of 1, which in this case it is already there, so we don't have to divide anything to get it equal to 1. And in this case, our f of x value is just going to be secant x. So writing that back into our matrices, we can say that it is going to be 0 sine of x, secant x, cosine of x. Cross multiplying, we will get 0 minus secant x, sine x, which is the same thing as saying it's negative tan x. Our w2 value is going to be y1, 0, y1 prime, and secant x, our f of x, which our y1 is going to be cosine x, negative sine x, 0, and secant x, which, cross multiplying it out, we will find that it is cosine x secant x minus 0, which is just equal to 1. Now, with these values, we are able to find what our u1 prime is. So u1 prime is going to be equal to w1 over w, which is saying negative tan x over 1 is equal to negative tan x. And our u2 prime is going to be the same as w2 over w, which is just 1 over 1, which is equal to 1. And now we need to take the integral of these two functions in order to solve for what they actually are. So u1, the integral of u1 prime dx is equal to the integral negative tan x dx, which is just the same thing as saying we can take the negative out. First things first, take the negative out. Tan x dx, which is equal to the negative of a negative natural log of cosine of x, which you can just write as natural log of cosine of x. Now our u2 value is, our u2 value is going to be the integral of u2 prime dx, which is equal to the integral of 1 dx, which is equal to x. Therefore, our u2 is equal to x. Now that we know our two values, we can take them and plug them back into our general equation and say, or not our general solution, but our yp solution, which will give us natural log of cosine of x times cosine of x plus our u2 value, which is x, and then our sine of x. Now, because the general solution of the entire thing is going to be equal to yc plus yp, we can say that our yc is going to be c1 cosine of x plus c2 sine of x. Now, our yp value, we have stated up here, is natural log of cosine of x times cosine of x plus x times sine of x, which is equal to y. And that is the general solution of this entire function, with our c1 and c2 values are arbitrary constants.